Hey guys, good morning all. Just give me a yes in the chat if you guys can hear me and see the sublime text. Quickly give me a yes in the chat if everybody can hear me and you guys can see the sublime text, or if you can. Cool. Let's quickly start with today's session. So till the last class, we were doing our second case study, which is built upon generating a social media application, just like Instagram, Facebook, Twitter, so on and so forth. Okay. We already had one session before that, so we're just continuing the same. We started with the newsfeed generation. So we talked about newsfeed generation and newsfeed publishing. We finished both of them by the way yesterday. So in terms of newsfeed generation, our newsfeed is generated from the post of users that we are following, right? So one way of doing that is I have to retrieve user ID of all the user and have whatever the number of people that I'm following, just follow it from the all the account. You need to retrieve the latest, most popular and relevant post, and then you need to rank them as per some sorting logic or some ranking logic. Then you store in the cache and return the top results, like maybe top 50 to be rendered on user timeline. On the client side, when the user will reach at the end of the current feed, they can fetch the next 50 feeds. Okay, so on and so forth. Now, how do you determine which factors will come into that? That factor will be interaction score or engagement score. How does he have the engagement score? Based upon multiple metrics that we're going to discuss in a few minutes. So there can be two different kinds of timeline. One can be a fixed size timeline, one can be an infinite timeline. Fixed size timeline includes, in the case of Instagram as LinkedIn, and the case of infinite timeline, which includes like Facebook. Now, in terms of ranking, how do we actually determine what part needs to be ranking? What are some of the parameters that needs to be taken care in terms of ranking? Which includes the number of interaction that you have with that user, which includes likes, comment, share, save, mention in the stories, captions, comment, post, chat, watch time, and tags, etc., etc. Okay. Then we talked about how to generate the newsfeed. So to generate the newsfeed, there are two ways. Either you can generate it online or on the go for newsfeed generation, or you can do it offline feed generation. Now take an example to understand. In the case of Zomato, we need the updated data. There's no possibility to give the stale data to the customer. That is why my consistency is more important than availability here. Okay. In this case of social media, I am not concerned about the consistency. People are not, or my customers are not concerned about whether they're seeing the most latest data or not. They need to see the data which keeps them engaged. Okay. So my priority is when anybody opens their app, there should not be any lag, there should not be any latency for them to load their feed. Okay. So my primary concern is availability as compared to the consistency. So if we talk about online or on the go newsfeed generation, let's talk about the issues. The issue is for the latency. We don't want to definitely generate homepage instantly. Number two, for users who are going to follow a lot of other users, for example, with large following, for them it's going to have, when you're creating it on the go, it's going to be very complicated. Why? Because you have to do all the steps that we discussed. You need to get their user IDs, you need to get their post, and then you need to rank them. If you're generating it on the go for people who have a lot of following, this is going to take a lot latency. Then for live updates, each update will result in creating new query to get the most updated result. And for celebrity users, live update will have very heavy load to push to content for new followers. So it doesn't make sense to do it on the go for newsfeed generation. What's the other part? The other part is offline feed generation. What about the offline feed generation? The offline feed generation is we have to do for structure. The structure of my offline feed generation is going to look something like this. A user ID and with pre-generated feed items, right? So let's say for this particular user, I would have list of top 50 items or 500 items, whatever I'm generating, and I'm parsing through the pagination logic. So my feed item can contain the content ID, the duration, the name, or whoever is the corner, etc., etc. Okay. Now we will have a dedicated service for offline feed generation, which will continuously generate user feed and store it in memory. Let's say we generate for 500 for each. And that also we can customize. We might not need 500 for each, depending upon the user behavior patterns and all. And for majority of the customers, we might not even need to do it in terms of inactive customers. Okay. Whenever user logs into their feed, we can immediately serve the pre-generated feed that includes of stale data, but which is completely fine. And for subsequent requests, they can run the dedicated newsfeed generation again. Once they have scrolled through all the 500 posts or whatever that we have generated, after that, they can ask for the data and then we can have some sort of latency working between our systems. So regular intervals have a lookup and the new feed items. So for the new feed item, there can be two updates. Either we can push the SSE server side events or we can let the client make the call. If we are pushing it from the server end, for example, if we know that our client is watching something which is quite a stale data and we want them to show a new data or we want them to show a new feed, in LinkedIn, we provide feature like new post and this, and we give the customers feature that they can click if they want to scroll over. And which does make a sense because we don't want to automatically refresh something on LinkedIn because people are doing something serious on that platform, right? In terms of Instagram, we can directly refresh because we know that people are scrolling through. So even if we directly refresh the feed, at least they will be able to see the new data, which might be more engaging to them. Okay. Another way is that a client can ask the communication that, hey, I've already exhausted it. Now I want to see more content, or I feel that the data that I'm going through that is quite old or stale data. So I want to have a new content. So in that case, client can pull or refresh the app screen, or even they can close and open the app. Both case, it will be counted as a new request and they will get the latest data here. Okay, this is how it will look like. Then we talked about how many feed items should we store in memory for offline feed generation. So we decide we can generate 500 items per user and 50 posts per page we can do it, and we can then scroll through 10 pages. Now, of course, obviously we can do optimization. We won't need 500 each for everyone. Based upon the user behavior pattern, we can do it. And of course, we have to avoid generating newsfeed for inactive users. Okay. We can also analyze the pattern which time they are active. So it makes more sense to get the latest update till that timestamp. Then we talked about should we generate and store in memory cache newsfeed for all users? The answer is no, we don't need to. So the users who do not log in frequently, there's no point of generating newsfeed actively for them. And we can categorize the users into segregation like passive users versus active users. Okay, so we can go with the LRU based cache. So I can remove the newsfeed for users that have not accessed newsfeed. And optimize ways, I can analyze the login pattern of the customer users and accordingly I can generate my newsfeed. So that was the newsfeed generation, everything in details of newsfeed generation. Now coming to the newsfeed publishing part of it. So newsfeed publishing part, the process of pushing a post to all the followers is called fan out. What is this newsfeed publishing part is, if I post something, how would that be propagated to all my followers? This is what we post as newsfeed publishing. Generation is something happening for me to see upon. Publishing is something I am publishing, how it is being propagated to all my followers. That is what we call as newsfeed publishing. Okay. So in order to do that publishing slash fan out, there are two ways. Either it can be pull model or it can be push model. What is pull model? Means client can pull the data on a regular basis whenever they need it. So what is going to happen is all my followers will keep an open connection. Open connection in the sense it's going to be short polling, and they will keep on fetching from my DB chart if I have a new update posted so far. Obviously, I will not be posting every second or whatever the duration is, 30 minutes, one day, whatever it is. That is going to lead majority of them to empty responses as supposed to be in the edge score or short polling, right? So it doesn't make much sense to keep that. Another model can be push model. In that case, the client does not need, client here we are referring to our followers. My followers don't need to keep an open connection. What they can do is once I publish a post, I can immediately push it to all my followers. So in that case, there will be so much less read heavy applications and I do not need to fetch every time for short polling. So this is how the flow looks like. You will check for the all following user IDs, check for the most updated content, too many read calls in terms of pull model. In terms of push model, whenever data is being published or whenever a post is being published, and we can, without any checking for the read calls, we can directly push it to the newsfeed for our followers. Okay. Although it comes with a caveat. What is the caveat? For celebrity users, which has a lot of followers, we're talking about greater than 1 million followers. If we have to publish or push update to million plus account, that is going to be very write heavy application. And for inactive users, push model is a waste of resource. So somebody can, let's say, have 200 million followers, and out of that, maybe let's say 1 million, 2 million followers are non-active, but you still push 1 or 2 million, which is not required anymore. Okay. So how do we solve this problem statement? We have an issue with pull, which is a larger issue. We have an issue with push, which is specifically customized for the celebrity users. So what do? We keep something called hybrid model. What does that hybrid model does is it's a combination of pull model and push model. So we go ahead with the customer segmentation here. So in that segregation or customer segmentation, we divide into two categories, normal users and celebrity users. In the case of normal user, I can directly go ahead with the push model. And what does that mean is for people with few thousand followers, you can directly push it to their updated content in their newsfeed. For celebrity users, I will prefer a pull model. So user can pull the data on demand basis whenever they need it. Okay. Again, on demand basis, there's not going to be any short polling here. Now, to understand that as an end customer, to understand that as user is, you can try it yourself and you will probably understand it. If you have, let's say, 500 following, 450 being normal user, 50 being celebrity users. Whenever you open your feed, which is a pre-generated feed, you will always find the post only coming from the normal users. If you refresh it or if you open the app again, only then in that case you will see a celebrity post and you will always see it on the top. You will never see a celebrity post in middle of the feed because that in middle of the feed is generated for the normal users, right? But when you refresh it, that is time on the go, it is being published to your part. Okay, that is for your pre-generated post. So refresh, you'll get the top celebrity user post, add the celebrity user post here. Then we talked about how does the engagement visibility of the viral post actually work. We talked about based upon geolocation, 10% and particular time. Based upon the 10%, it will exponentially increase to other geolocation. That's how a particular post becomes viral. All right, guys, this is something that we have discussed in the last class. Quickly give me clear. If everybody clear, then we can start with today's session. I'll answer the question in the chat, but before that, any more doubts, let me know. Okay, cool. Now let me answer the question. Is offline feed generation make sure latency is within 100 milliseconds? Good question. See, online for definitely for sure will not make 100 millisecond. Offline is the way to go for it. Now coming to non-function requirement, right? Any approach does not align with or talk about the metrics how you're generating. So you have to make a decision between online versus offline. Offline is definitely higher latency. That's why I go for offline. Inside the offline also, whenever you have certain SLAs, for example, 100 millisecond, 50 millisecond, that is dependent upon how you're implementing it. So in terms of offline feed generation, what we'll be implementing is after doing the optimization we talked about for non-active accounts, we need to have a really good cache service on top of it that will make sure latency will remain within 100 milliseconds. That's the whole purpose of cache. Okay. All offline feeds for all users cannot be held in the cache, so they should be persisted in the durable storage. What are the options for persistent storage? As I said, offline feed generation, that is a correct statement. Offline feed generation is always going to be a new service. That new service can be another storage. It can have its own storage. One microservice can have its own storage as well. Not everything needs to be in the centralized database. But the response will get it from the cache. And it's not necessarily that my cache cannot contain the data. It depends upon what you're storing in the cache. Remember, we don't need to store entire content there. All we need to do is something like this. If I show you this part, this content is going to be a reference, right? Whatever the path of that content, my path is already there in the content file or S3 file. So whatever is that path I need to provide here. So it's going to be a context here. Okay. So even in a cache, you can store it if you want to, depending upon how you're implementing or whatever the structure of your newsfeed you want to store. So if you look at per day basis, when I have to create a newsfeed generation, and assuming I don't have to create for offline accounts or non-active accounts, you can do it in a cache also, right? Depending upon what structure or what schema you want to do it for a pre-feed generated items. And if it requires a storage, then you go ahead. But if it is not required, you can just keep it in a cache or multiple servers of cache and then fetch accordingly. Okay. All right, guys. If that is good, we can move on to the next question or today's session. Cool. Question is how many items, how many feed items, that's the item, to return in each request. How many feed items do I need to return in each request? So in terms of my feed, in one request, we can have, let's say 50 items. Now, here is something which is important, which we'll talk about here. Bitrate adoption. Okay, we'll talk about it. Now, depends on client device. This is something good and important to talk about. When we say how many feed items to return in each request, it is not always constant. Okay, it's not like every request has to generate only 50 items. It will depend on your client device and will also depend what bandwidth you're operating. Okay, and bandwidth. So either you're using via mobile or you're using desktop, so on and so forth. Okay. So my client devices, for example, laptop versus mobile devices. For mobile devices, the data usage is very expensive. I'm talking about the data usage, not the Wi-Fi. Okay. What do you mean by expensive? You would have noticed this if you try to use or scroll Instagram for maybe let's say a couple of hours on your mobile data, you'll probably easily exhaust up to 1 GB or 2 GB of data. If you have not tried it, you can try it. Okay. So my mobile Wi-Fi I have the option that I can consume more bandwidth. Okay. But in my mobile data, I have to consume less bandwidth. What does that mean? What does that mean for our bitrate reduction? So think of a use case. I'm taking one example, then I'll go to another one. Instagram. And even before Instagram, let's take example of YouTube. Bitrate reduction is a very smart technique, which is done as part of an optimization to ensure that a customer is having a good customer experience. Even if they are in a zone where the network connectivity is not very good or the internet connectivity is not very good, but still they're able to have a best customer experience possible. So let's start with YouTube because that's more familiar, and then we'll talk about the case of Instagram. Let's say two users are watching the exact same video from two different parts of the world. Okay. So let's say user A is watching on mobile and is connected to 5G network. And user B is also watching in mobile, but he or she is using mobile data and connected to, let's say, a 3G network. Same video here, same video here. What do you think will be the difference in the video they're watching? Come on, guys, quick in the chat. Correct. Video is load will 720 pixel for this guy or 1080 pixel if he or she has suggested that's quality. By default, it will choose the best quality that you can filter for. And for this guy, it will load in 360 pixel or maybe whatever the best quality available. Now, the important part here is to understand something. What is that bitrate reduction is depending upon whatever bitrate your network is receiving, right? Bitrate is nothing, number of bits you are transferring per second, right? Whatever the bitrate your network is receiving, you adjust your customer experience according to that. What does that mean? Understand the simple example. You are watching a video on YouTube, let's say, right? And you're connected to a Wi-Fi. Suddenly, your Wi-Fi gets disconnected, but still connected to your mobile data. So that video which you were playing in 720 pixel for that duration of 1 or 2 minutes or 5 or 10 seconds, it will be 360 pixel and then it will back to 720 pixel. Have you guys noticed it? I'm pretty sure everybody would have noticed it. I mean, they may not have experienced it, but you guys would can definitely notice it. You can connect your mobile data and your Wi-Fi, play a video and using Wi-Fi, disconnect the Wi-Fi for a few minutes, and then connect back the Wi-Fi. You will see the notice a difference in when you're playing it on a mobile data versus when you're playing it on a Wi-Fi. Now, here's the interesting part. There can be two choices which can be made here. When the customer lost connection with Wi-Fi and they were watching in 720 pixel, one way of thought is we will wait till it gets connected back to the Wi-Fi and will not play the video at all. And number two, we can still continue to play the video. It's just that we'll reduce the quality based upon our current bandwidth. Which one do you think is a better customer experience? Come on, guys, quick in the chat. Obviously, option two. See, rather than making sure that the video has to be always the highest quality, but making the customer wait for it because sometimes it's not in the customer hand to connect back always, right? So rather than watching a screen which is loading all the time, that's a very bad customer experience. So that is what we call as bitrate reduction. Instead of doing that, whatever current bitrate is available to us, we can deliver the content according to that. So for an end user, it's an unlimited or seamless experience. They will not be able to notice whether it has been playing or not playing. Okay. Same example in the case of Instagram also. So the use case here is see the Instagram on two devices, case one and case two. Okay. So if there is a mobile connected to a very high speed Wi-Fi, let's say 5G, Then the default size for fetching newsfeed would remain 50. But let's say client does bitrate adaptation and not backend server. No, no. When we say bitrate adaptation, we're talking about the network in which they are connected to. Okay. So think it this way. You are a client and there is a server. There is a network via which you guys are connected. Okay. Now, depending upon how you're connected, it can be a mobile data or it can be a Wi-Fi. The only difference it makes is whenever you make a request and our server giving you a response, how much per bit you are able to transfer. And that will be dependent upon how you are connected with. Okay, your download speed, upload speed, that's what you refer to. Download speed, if server is responding, how quickly client can intercept that. Upload speed, when a client is making a request, how quickly it can go through the server. This part clear? That is what we are talking as bitrate reduction. Are there different resolution version of same video? Yes, yes. They are not created on the fly. They are already stored in the YouTube or whichever platform you are storing. Okay. That is called codec decoding, which we'll discuss when we go to the YouTube case study. Anyways, coming back to it. So first use case, when a mobile is connected to a very high speed, now we are talking about the use case of Instagram. If it's connected to a very hi-fi device, let's say for 5G. For second case, when a mobile is connected to a very low speed data, let's say maybe 2G or 3G, then we can have default size for fetching newsfeed equal to 20. Okay. Why is it so? Because we'll prefer to show less number of posts on newsfeed in shorter time versus more number of posts on newsfeed in higher time. Okay. So my 50 posts, let's say, take 5 seconds versus my 20 posts take 1 second. So I will prefer this one on low bandwidth connection. Okay. One moment, guys. Let me revise this, then I can answer the question. For the case of YouTube, whenever you're watching the video is already available in multiple qualities. You can go to the settings, you can check all the qualities wherever it is available. It's available in 360 people, 360 pixel, 480 pixel, 720 and 1080 and maybe some videos 1080 and some videos on the 4K as well, right? So those encoding is already present on the YouTube end. So whenever there is a dip in the network, what you can do is you can switch to the best available network or the best available bandwidth for that. And you can show the content according to that. And whenever it is back, whenever your system is back, whichever the next bandwidth available or the highest bandwidth available, you can show it. So the customer always have a seamless experience. This part clear to all for the case of YouTube. For the case of YouTube, we have multiple encoding already present. You just choose the encoding based upon the bitrate you are getting. Okay. In the case of Instagram, we do not have multiple encoding as such, which is done in the case of YouTube, which does make sense. The purpose of Instagram is not to create multiple encodings. Instagram, let's say there is a reel. I'm just taking an example of a reel because that's going to consume the most bandwidth. If there is a reel, let's say the reel is available in 480 pixel, I cannot enhance it to 720. I cannot reduce it to 360. If it is 480, it is 480. How you are saying on a laptop is the same how you'll be saying on a device, a mobile device or some other device. And it's the same if you're using on a mobile data or Wi-Fi. So we do not have the bandwidth to change the encoding here. All agree? In the case of Instagram, we do not have multiple encoding, so we don't have the bandwidth to show the encoding based upon bitrate. But we have one option here. What is that option is? I can decide the number of newsfeed items I want to show, right? Whenever I'm generating the newsfeed items, I can decide how many items I want to show. So If I know that my customer is on a very well-defined network, a good high-speed 5G connection, I can show them 50 feet. Let them go through 50 feet. Whenever they want more, I can push more, right? Easier customer experience. But if I know that my customer is currently at a place where the bandwidth is not that good, so instead of generating or pushing all the 50 feet, what I can do is I can give 20 feet. If the customer scroll 20 feet, I can give another 20 chunk, and so on and so forth. I cannot change the quality here. I can change the quantity of the items I'm generating in my pagination logic. Okay, so that is done. Why it is done? Because common sense for a good customer experience. If to send 50 posts, the higher number of posts you will send, the more time it will take you to generate it, right? Generate in the sense, send it to the customer. So if 50 posts sent takes 5 seconds versus 20 posts sent take 1 second, I will prefer to show them less post, let them go through that post, and then I can send small chunks of it. Rather than sending a bigger chunk, knowing that they will not be able to watch all of them, considering they're coming from a low mobile data. This part clear to all? Come on, guys, quick in the chat. This part clear to all? Okay, cool. Now let me answer a question that I saw in the chat. Backend servers send different resolution images. I already answered. They do not send the different resolution images. Those are same. It's just that the number of posts that you'll be seeing, that will be different. We do not create multiple encoding, decoding in Instagram. We do that in the case of YouTube, Netflix, streaming services. Okay. All right, guys. All good. Then we can move to number 8. Quality adoption will work when selected auto on YouTube. It will by default work even if you don't select auto or anything. Let's say you're watching on 720 pixel. That's what I said. The devices or the servers are smart enough to generate the best user experience for you. Okay. You don't need to select any auto. Even if you put like, let's say 720 pixel and play the video, disconnect the Wi-Fi, connect it with your mobile data. The video will still play. It's just that it will not play in 720 pixel. Okay. All right. Let's move on to number 8, which is feed ranking. Okay. Now, what do you mean by feed ranking? We already discussed upon that, so just documenting it. One moment. How does backend server know how is my connection? Backend server knows a lot of things when you connect with any server. See, understand. Even with the mere HTTP connection, there are too many things that you are sending the details to a server when you're connecting. Okay. Your IP is not the only thing that you're connecting. There is IP, there is headers, which includes your location. IP also you can track the location, by the way. Multiple headers, and in terms of that, the way you are making a connection request, from that connection request, the response that you got in a packet, that tells us the bitrate speed. All of those details are present in the HTTP connection that you make. That's how backend server intercepts it. Okay. All right, guys. Coming to the feed ranking part, let's talk about it. Factors contributing to ranking in feed. Let's talk about this. So I think we already listed that. I'll just take those items and push it here. Multiple factors will determine like this, like comment, shares, and everything. This will determine how do you generate a feed ranking. Okay. And finally, you will have an engagement score. That engagement score will determine the newsfeed. Okay. Number 9, data partitioning or sharding. Now, this is important, data partitioning and sharding. How should we partition our database? How do we shard our database? So for my newsfeed generation, we can use DB sharding. Now, multiple billions of users, you're going to generate newsfeed for them. How are you going to get the content populated for them? Let's talk about it. Now, there are two options. What should be my partitioning key? Should it be a user ID or should it be a media ID? Let's talk about both of them. Okay. If I have to shard my databases, does it make more sense to shard based upon the user ID or does it make more sense to shard based upon the media ID? Now, let's say I start with media ID based sharing. Do you see any problem with media ID based sharding? What if my database is sharded based upon the media ID? Media ID is content ID. In the DB schema, when we defined, it's not here. In the previous class, when we talked about DB schema, media ID is just the content ID. So every content will have a unique content ID. Yep. But guys, do you see any problem with content ID based sharding? Maybe slower in different regions. Okay. All. Okay. Anything else? Uneven distribution? Anything else? Too many shards? Okay. There can be billions of media, there can be billions of shards. What else? Content ID is unique. Yes. Media ID content ID is unique. We have to make it unique. That's how you can shard it, right? What else? Anything else? See, too many shards, is it a problem? Not exactly. What is a problem here? What can be a blocker here? Having more number of shards doesn't sound as a blocker. What is something which is a critical blocker here or can be a critical blocker? Joins. Okay. Anybody else? One guys quick in the chat. Cool. Let's discuss the answer. Media ID based sharding every user goes to multiple DBs to get data, keeping a track of shards. Okay. All valid concern, but let's talk about the elephant in the room here. What is the biggest problem with media ID sharing? Number one user can post a lot of content. Okay. If you talk about profile page of a user, profile page is supposed to list all contents posted by a user. Okay. And let's say you have a user or you have, let's say, these accounts or pages which have more than million posts or thousand and 100,000 or maybe a million posts. In that case, to generate a profile page for that particular account slash page or user, you need to go to all partitions. You need to merge the responses for that particular user, and then you need to return it. That will make it very slow because for every media or every content that you're going to have a read call in, then you have to merge it together and then you have to sort them by whatever logic whenever it was posted recently, right? So anti-chronological order. That will make it very slow. So if we go ahead with such kind of media ID based sharding, whenever you're going to see a profile of a particular account which has a lot of posts, it's going to be extremely slow. All agree? Okay. Even bigger problem. Now, you may argue that there is not many people or there's not many accounts which post a lot of content. Valid assumption, nothing wrong. So it's a problem, but may not be a very critical problem. So you can say we can do some optimization and we can do things. Fine. But even bigger problem is too many people can post the same photo. Or think about viral post. Okay. Viral post will lead to uneven distribution of load on media ID sharding. Media ID base sharding. What does that mean? Let's say there is one media ID and I'm talking about only read calls here, read request. I have M123. I have M456. So if it's a media ID based shard, let's say one of the reel got 10 views, another reel got 10 million views. If you create a shard, this is also one shard, this is also one shard. But look at the indifference in the amount of traffic. One shard is responsible for only 10 requests, other shard is responsible for 10 million requests. This became viral. What happens in this case? If there is such high imbalance on shards, it makes sure that you have not done the sharding properly. So keeping a media ID or content ID based sharding is not good for multiple reasons. Number one, if one particular user posting a lot of content, it will have a very hard time in generating a profile page in optimized time. And number two, for the viral post itself, you will not be able to generate or handle the load. This might further require sharding again. Okay. This might further require sharding again, because then you would have to create clustered level of sharding because you got too many views or too many traffic on that. Okay. Everybody's clear to this? One moment, I'll answer your question. Everybody's clear to this? Okay. So one thing is clear, content ID based sharding is not a good idea. Okay. But it's good to talk about so that we know which one to eliminate. To your question, how do you map to a different shard? See, whenever you create a database and you have option to create a shard, you can define the key for that. So for key, I can define a content ID, and content ID is always unique. Okay. That's how you can do it. All right. Now coming to the solution part. What we should do in terms of sharding. Solution part is we are going to keep the sharding slash partitioning key as user ID. It saves me from the problem of viral post. I don't have to go for a one particular shard and too many load on that. And it gives me the information of one particular user under one partition. Okay. So I don't have to go through multiple partition or shard to get the information for a user. There is no need to aggregate responses from multiple partitions. This is the answer. Okay. Now there can be another case which I would talk at the end, which is what if two people post the exact same content? How are you going to make sure in my database, let's say in my S3, I'm uploading one copy of it? Okay. So think it like multiple accounts or multiple channels posting multiple videos, exactly same videos. But at the end of the day, you know it's the same video, right? So does it make sense to upload multiple versions of it just because multiple people posted it? Or do you think in terms of that, you should reduce it and create only one replica of it? Come on, guys, put in the chat. Aggregation will be required to put the feed together for all the following users. No, that's just a user ID mapping, right? See, what we are talking about is we need the information of a user under one shard. One moment, guys. We need the information of a one user under one shard. Whichever content they have posted, we'll get it based upon user ID based sharding. This mapping that we created in the DB schema we talked about, that's going to be a follower following mapping. So that is a 1:1 schema that we are already keeping in a Postgres. So we can just fetch that Postgres, we can do that. When you click on that profile, that is when it will come into picture. But if you're just checking how many followers, how many following, you just have a 1:1 mapping for it. Okay. All right. Anyways, that question I discussed, think about it. I'll come back to it later. My question was, let's say if multiple people, one moment, posted same content. This is my question here. In my S3, wherever I'm uploading the actual content, how to keep, or forget about how to keep, should we create multiple copies or keep only one? That was my question, by the way. Okay. To get shard, we'll pass user ID, content ID to hash function to get the shard number, user ID, not the content ID, user ID. Yes. Okay. How the well post process work in user ID based sharding. So in a user ID based sharding, you will get the post based upon one particular user. Now, those posts of a user which will get those posts of a user which will get a very high number of traffic, basically those become viral. For that particular user, we can further shard it. Okay, for example, on one particular user, the view has become extremely large, right? Or the content based upon one user become extremely large. In that case, we can further partition those. But those are going to be very limited cases. All right, guys. All good so far? Let me know the answer for this one. Till meantime, I'll move on to the next topic. Keep only one and map with the user ID. You can think about it. I'll ask this question once we touch that topic again. Okay. How identified the content was previously posted? That is what the question is, right? Should we identify? Should we not identify? And so on and so forth. But that question is for later once we discuss at the end. Now I want to cover the other parts like caching, load balancing, and stuff. Okay. So let's do caching. All right. Guys, if you're answering keep only one, also try to think about how are you making sure it's kept as only one, right? Same question somebody asked. How are you going to make sure that how do you identify it's the duplicate as how it was shared before? Okay. All right. Coming in terms of caching, we can pretty much reuse what we discussed in URL. I don't think there's anything else required right now. So we had URL in, I guess, class 9 and 10. Let me open it. This is class 9. Yep. Let's take the caching part here. Nope. This cache and load balancing, we can just keep as it is. Nothing would change it. Okay, there you go. Let's modify the numbers wherever we need to. So which cache? Let's try to answer the question first. Redis works completely fine here, keeps multiple replicas here. So Redis is the one which is going to be our choice. Just highlight it here. Quick lookup in the cache will do. That's how you will do it. In terms of size of my cache, what do we need in the size of my cache? This is a huge scale, 80% rule. I'm just going to remove this. I am going to cache here 20% of my data. And we did those numbers calculation earlier. To store 20% of request, my cache was required as 400 GB per day, if you remember in terms of when we did the capacity estimation for Instagram. So 400 GB per day. Remember, cache is a short-term link, so I'm only concerned about one day. 400, I don't know if it was GB or TB. Let me check those number again. This is class 10. What we talked about? Yeah, let's see whether it was GB or TB. So cache we talked about, okay, we already talked about 80 terabytes. Good. That was 400 TB. We already had those numbers here. So I'll do this. It's already here. Good. So to store that, we are going to have 80 terabytes of cache memory per day. Now, 80 terabytes is quite huge. So probably we need multiple servers for it. Okay. Which cache eviction policy? Let's talk about that. When the cache is full, we want to replace what? We want to replace a content with a newer content. And LRU can be a good solution. Discard the least recently used content, store the new content. That's it. Cache in this case, this is fine. Nothing will change here. Okay. That's all on the cache part. I can close this one. I can close this one. Now coming to the load balancer part. Which policy to use? Round robin. And now in terms of adaptive solutions, we get the predictive analysis. So we'll continue with NetApps. Okay. All right. One more thing to add here, and then I'll go to the last question that I talked about. Analytics, already viewed post can be evicted. One moment. Yep, cache eviction policy. So in terms of my cache, the data which has not been accessed so far that I can remove real quick. Or depending upon what we are keeping in the cache here, in the cache we are storing the content here, right? So we can either think upon MRU where the content is already viewed, we can remove it. But it makes sense to keep the content which is viewed because that content has more chance to be viewed ahead. So think of this way. I have a cache. Let's start very simple. I have 5 content. If a particular content is being very frequently, right? In that case, it makes more sense to keep that content in the cache because that has been viewed. But if a content has not been viewed before, it doesn't make not viewed before in the sense if a content has been least recently used or least recently viewed. In that case, it doesn't make sense to keep that content. So when I say least recently used, I'm referring to least recently viewed here. Okay. So whichever is least recently viewed versus whichever is most recently viewed, accordingly, we can keep it in our cache. Whichever is most recently viewed makes sense to keep it in the cache. Okay. All right. Now let's move on to the analytics part. We can have some analytics and telemetry here as an extended requirement. Viral post will often handled by cache, right? Viral post needs to be there in the cache for sure. Okay. If you're directly accessing from the database, it's going to take a lot of time. Non-viewed posts will qualify as least recently used. All non-viewed posts will, again, as I said, the least recently used, I'm referring to least recently viewed. So yes, non-viewed posts will be the least recently used. Okay. So we already have the cache, which is for our newsfeed generation service. And here I'm talking about the cache of the entire database. How do you want to filter in your newsfeed generation versus newsfeed publishing? That you can decide. Okay. All right. Coming to the how does backend know which post is going viral and put in cache? How does backend know which post is going viral and put in cache? Number of likes, number of views, number of comments. These are all the analytics to determine whether a post is viral or not. Okay. Number of views is the first one, and based upon that, the likes and comments will do. Comments can be restricted, so number of views and number of likes is the two major metrics which determines the content is posted. Okay. All right. Newsfeed publish cache would be different, right? That's what I said. I'm talking about the cache here, which is the database cache or the primary cache. In terms of my newsfeed generation, which is separate service, it can be a cache as well. But the logic would remain the same, right? Even in the newsfeed generation cache, we will be storing. We don't need a primary storage. That's what I was answering the first question somebody asked. In that case, we can keep only the cache part. And in that cache part, we'll be keeping a structure like this. Offline feed generation, something like this. Okay. But both of them will be storing the content. It's just that in that cache, we'll be storing mapping like this. Cool. Now coming to the analytics, I think we did discuss it, but anyway, let's continue. We can have some event processing here for sure via EQs, my event. Okay. There are multiple events here. In this kind of a system, there can be multiple events. Events in terms of somebody mentioning in the story, somebody tagging them, somebody commenting, liking, sharing. All of those can be events here. Okay. So I can generate a Kafka event for every trigger, like, comment, tag, post, etc. Put that event in an EQ or analysis. And on top of that, we can run Apache Spark and Hadoop queries, okay, to get more insights into customer behavior and suggested contacts. Basically, that's how your recommendation engine is built upon. So if you watched a particular content, how much did you watch it? Did you complete 100% completion of it? Did you drop off in between? Did you like it? Did you comment it? Did you share it with someone else? All of those events will be captured here. And that will help us understand, or that will help engineers understand from their backend whether do you need, or the models will help you understand whether you are more interested in that content or not. So next time when you open the feed, more content will be shown to you depending upon whatever data inputs it has gone so far. Okay, from this analysis. Cool, guys. If everybody's thing, now let's move on to the question that I asked. There you go. Let's start with this. So my question was, multiple people posted same content. In your storage, should you create multiple copies or keep only one? Okay. So Kafka mainly for messaging queue purpose, right? How it will capture the user behavior. Kafka is, okay, one moment, guys. Kafka is used for passing an event. It's providing just a channel where you can hand the event. You can use it for any purpose, correct? So messaging queue can be one thing, but what we are using Kafka is for sending events. So there can be multiple reasons or multiple ways I can utilize my Kafka channels. Obviously, there will be two different channels, one for messaging queue versus for this. The purpose here and what I'm talking about is, depending upon how do you want to generate a recommendation engine, we need those signals. How do we get those signals is based upon the metrics, for example, likes, comments, tags, post. We can have these events and we can run queries for Hadoop to get insights based upon customer behavior. For example, I can have category A, category B, category C of content, and I can see category get 20%, category B like 40%, category C like 32%. So based upon that, I'll be showing category B to the users. That's what I was referring to. Okay. Newsfeed generation service will need to interact with the recommendation engine. Yes. Generate some hash, keep only one copy, create basic to encoding, all of this. Okay. Cool. Let's discuss about this one, guys. Some of you already started answering. Let's go step by step. Generate some hash for the image before storing to S3. Determine whether it's a duplicate. Keep only one copy. Create basic to encoding data to check the duplicate. Okay. See, I think we sort of discussed this because I do remember discussing generating hash before we uploading to S3, capping all those checks. I don't know which case study we discussed because it's the second case study, but we did discuss about it. Okay. So first thing first, does it make sense to upload the same media ID, let's say M123 is posted by 1,000 users? Does it make sense to upload the same media 1,000 times on database? The answer is no, it does not. So in your S3, one moment, guys. That's how you have to find out the media ID, right? So before you even see, if you're not able to, first thing is first, you have to understand whether it's a duplicate or not. If you don't make it as duplicate, then obviously it's a new media ID. And media ID is generated after posting, not before posting. Correct? Once it is successfully posted, then in the response, you will get a media ID attached to it. So if you're saying it's going to be already a different media ID, means you have already uploaded on your S3. We're talking about before uploading to the S3. So first thing first is to understand the content that is I'm about to post in my S3. Is that content already available or not? First thing first is to make sure we identify the duplicates. All agree? There are two parts to it, guys. One part, first, identify whether it's a duplicate or not. And second, if you identify as a duplicate, do you still want to upload it or not? That second part we just answered here. If it is a duplicate, we can reuse the same one. But the first part is we need to identify if it's a duplicate or not. Okay. So in S3, whenever you do a file upload, you are going to do a hash code. Okay. Different user can post the media ID and will have different media IDs. They can, yes. See, what I'm saying in terms of media ID is not necessarily combination of user ID plus timestamp plus counter. Okay. So think of any content ID in general. What I'm saying is, does it make sense to keep a duplicate media ID every time, right? We don't need to. We need some kind of an algorithm to identify whether that particular ID has already been there or not. So whenever you have new file to upload. We are going to check the hash code if it is present or not. If it is present, you should reuse the previous ID. One moment. Reuse the previous hash code. Else, you are going to upload it. As simple as that. Now, for end customer, they will definitely see two different IDs. For end customers, they will definitely see two different IDs. That ID is the post ID. What they are seeing on their screen, something like this. Instagram.com/post/ maybe post ID and whatever 1234, whatever that number is. Okay. I'm not talking about post ID here. I'm talking about the content ID which is uploaded in S3. So even if let's say 10 people have posted the same video, that doesn't mean I'll stop 9 other people to post the video. Or that doesn't mean that they will be posting the link of other people's Instagram. I'm not saying that. What I'm saying is internally, which is not exposed to the customer, so customers have no idea about it. Internally in my server, if I know that there are same medias being uploaded by multiple people or multiple requests, it doesn't make sense to upload all of them in the same S3 storage because eventually I'll die out of the storage that way. So what I will do is I will try to optimize it. I will, whenever a file of media is there to be uploaded, I will see if this hash code is present in my system. Now, obviously, that hash code can be multiple hash codes. So it can be a combination of your base 64 encoding plus SHA-252 plus multiple others. And we definitely need hybrid hash coding here because the content that we are dealing with is dealing with the billions and billions of posts. So there's a very high chances if you keep one moment. So there's a very high chances if you keep it only one particular algorithm, you will end up in collision. So that's why I need multiple combinations here. Multiple combinations of hashing. Okay. So reduce the chances of collision here. And then if it matches, then in that case, I'm going to reuse my previous hash code. Okay. Post ID will be just generated whenever user has confirmed the post. That doesn't mean as part of a post, your media will actually be uploaded. Maybe it's just utilizing the same media which is already present in the system. Okay. All right, guys. This part clear to all? Okay, let me check. What is the original image was uploaded by user, deletes that post. So what happens in S3? Consider the post is duplicated by other user. So before uploading anything, that will be checked here. So if that is deleted, if the original post is deleted in that case, that's a good edge case to talk about. It always creates a replica of it. Again, when you say a post is deleted, that post will be deleted. That post ID will be deleted. It doesn't mean the media ID will be deleted as well. Okay. So think in this way. If there is a media ID, think it like a graph traversal. Okay. And there is user ID 1. Let's make it as user ID 1, user ID 2, and user ID 3. So these guys would get their post ID 1, post ID 2, and post ID 3. Okay. Understand it this way. It will be easier for you to view. Now, same media was posted by 3 different users. So if I have to talk in terms of an array traversal, your root is media ID here. Children are user IDs. Okay, think it this way. Now, what will happen here is, one moment, guys, one moment. That's what I'm answering here. So if one media ID, what you're going to do is you're going to a root tree traversal. Think of in terms of a tree traversal. This is my root. These are multiple users. If there's only one media ID which is posted by multiple children, right? So if one of the node got deleted, let's say user ID 3 has deleted post ID 3. Copy this, paste it here. User ID 3 has deleted post ID 3. So this is removed from your node. If this is removed, so this will be removed as well from the node. Agree? Now my tree structure would be like this. If the post ID 3 is deleted, then user ID 3 will not have any purpose here. User ID 3 was connected to this particular tree because the media ID was same. So the post ID itself is deleted, user ID 3 will be deleted as well. Agree? Come on guys, quick in the chat. Okay. Does that mean my media ID should also be deleted? No. Why? Because my media ID is still used by the other two posts. If it makes you any easier, let's make it this way. Okay. Now you can easily understand what I'm trying to say. One moment. Okay. Let's make the children as post IDs. Okay. And then post ID can be tagged to the user IDs. So this is what I was referring to. Let's say one post got deleted, which was referring to this media ID. Whoever user was there, they will be deleted from this node as well. That does not mean the media needs to be deleted here. The media will still remain the same. Okay. All right. Let me explain again. One media was posted by three different users. Okay. Exact same video. Let's say one reel. One reel was posted by exact same three accounts. Okay. So somehow like this traversal would graph could have been created. One media ID, it will have post ID 1, post ID 2, post ID 3. They all post have the same media ID. Post IDs can be different depending upon different accounts. Okay. So post ID 1 is posted by one user. This is posted by some other user. This is posted by some other user. Now, let's say this user decided I want to delete this post from my account. Okay. So they deleted the account. That doesn't mean that particular media from S3 should be deleted. If it has more children, it should not be deleted from my S3. Okay. Media ID would not be deleted from S3 as it has more children present. Okay. But on the other hand, let's say if it was media ID and one user ID and one post ID. If it's by only one user and unique, deletion of post will delete the media ID from S3. Okay. I hope now it is clear to all. If it's a unique mapping, in that case, it makes sense to delete it from the S3 itself. But if it has more children present there, then in that case, just because one particular account is deleted, that does not mean I should delete it from my database altogether. Okay. All right. Now let me answer some of the questions in the chat. Hash code generate for image based on pixels in image. Hash code generate for image based on pixels in image. Nothing with the pixel as such. There can be multiple hashing algorithm to be used here. SHA-256, SHA-512, so on and so forth. Okay. If we download the image and resize it and add watermark or something, does it have same hash code? Same question that you can ask for YouTube also. For example, if you take a shot out of it and you try to upload the video from one particular shot, does YouTube count it as the same or different? Okay. So the answer is 100% it is not counted as different. It depends on the efficiency of the algorithm. How do you identify whether it is duplicate or not? It's not 100% accurate. Okay. Either at Instagram or at YouTube. So if you make some modification, depending upon what level of modification you have made, it's able to identify whether it's duplicate or not, but not 100%. Okay. Does it mean if I delete a post from Instagram, image would not deleted in S3 remains already answered. We keep reference count along with hash code, reference count becomes 0, delete from S3 as well. Okay. Do we need separate table to store the hash code, or we can handle that delete scenario when using the foreign key relationship? This hash code is generated on the S3 itself. This is generated on the S3 itself. Why do you want to store the hash code for it? Okay. It's keeping on the database layer, not in the application layer. If same image with different qualities provided, only one copy will be inserted into S3. That's what I said. It's not 100% accurate if you make some modification to the content, not just image. For example, if you crop it, you confirm quality instead of quality, you change the dimensions of it. Will it be able to identify as two different things? It depends on how efficient the algorithm is, and it's not 100% efficient. Okay. All right. Cool, guys. Everybody crystal clear with this? This is the end of our Instagram or in general, any social media platform, how to be built. So two, three main components in it. One main component was newsfeed generation, newsfeed publishing. And prior to that main component was the DB schema. How are we going to generate the DB schema? Okay. Now we can move to our final design, which is phase three. We started from phase one and phase two. Let's take a final design for phase three, and then we'll move on to some other case study. One moment. Let me answer you. Diagrams, Instagram. Okay. Now let me answer the question. How long does system design interview happens? 45 minutes. See, 45 minutes is just one moment. 45 minutes is the standard time for any interview. DSA coding questions, two, system design, one interview question. Okay. And out of those 45 minutes, take 5 minutes for introduction. So more or less you have 35 to 40 minutes. If two same videos uploaded but different time duration, will it be a duplicate? Same thing, guys. If you change modification of a particular content, either in terms of editing it, either in terms of adding more features to it, or adding a watermark or changing quality of it, or even with different time duration, it all depends how efficient algorithm determines or flag them as duplicate or not. Okay. A simple way to understand this in real life is in YouTube. I don't know how many of you have tried posting it. If you try to upload a video on YouTube, there is a part which says pre-processing. In that pre-processing, it will go through regulatory checks and will check through violation of right and so on and so forth. So if you put any music without a due right to it, it is going to flag your particular content without posting it. When you upload something on YouTube, YouTube does not immediately push it like Instagram. YouTube takes some time, does the check first, and then upload it. Same feature is not there in Instagram, and it does make sense because if you give this kind of experience to a user that, hey, it will take 10 minutes or 20 minutes or maybe 2 hours to upload your content, customers not like it. So even whatever backend processing you're doing in terms of optimization or not, end customer is not concerned with that. Here, end customer is concerned because if somebody is posting a video on YouTube, it has to be made sure that you are not copying some data or you are not having an infringement of a right? You can get the strike later also when somebody reports. It's not like it is 100% accurate, but they try to do check from their end while you're uploading a video. Same thing we cannot do for a social media for sure. Okay. All right. Let me answer this. In case user mark the post archive, the association with the ID will remain. Only the post will be marked as archive. Yes. The association will still remain. Each request has to go to DB to increase the counter. If the post becomes viral, too much of it will go to DB, which can increase latency. How to minimize the latency. So that is a good use case, which we'll discuss here. Where are we right now? Here. I think there was somewhere I flagged it to discuss. So the like is a different use case, and that actually happened in Instagram, which we'll discuss about, but not in the Instagram case study. I think I had one more case study here. Anyways, I'll discuss that case study when we'll talk about Facebook or something. That problem actually happened. One moment, guys. Let me answer that question. That problem actually happened. For every like increase, we don't need to go ahead and update in the database because the number of likes can be huge. It can be in millions, not billions for sure, but it can be definitely in millions. So for those, we are not directly updating in the database itself. What we're doing is just to give your answer short. I'll discuss more detail into it, and that's a very popular case study. You can search about Justin Bieber like paradox, something like that. Okay. This was the first thing which has actually broke the Instagram server. Okay. What actually happened is Instagram never estimated that it will reach the number of likes of 1 million. Justin Bieber posted something in 2016 or 2015, I don't remember the exact year, and it reached 1 million likes. And at that time, the Instagram architecture was like that it has to update every like in the database. That got so much load on the database, and they were using, I'm not sure what they were using. I don't think they were using S3 at that time. I think they were using something else, Celia or something they were using. And by that time, it hits 1 million likes, write calls. That is when it broke that post down completely. And that's why they have to re architect everything in terms of number of likes. So, more or less, what they did was they are not updating the database directly on the likes. What they're doing is they're keeping the schema on the content level. So, content will contain how many likes, posts, comments are released there, all part of the metadata. So, it's not updating directly in the databases. Okay. All right. That was answer to your question. Instagram song post got removed later on the basis of copyright violation. So a different service must there is which is performing these checks. Post got removed later on the basis of copyright infringement violations. I mean, I have not seen it. There might be. If somebody posted that or like somebody reported that this is a copyright infringement, then they are doing it for sure. But I don't think, or at least I'm not aware if Instagram is a separate service which is checking out later. It does have a service where somebody reports your post and it can be flagged under multiple things. It can be marked as duplicate, it can be marked as harmful for society, so on and so forth. In that case, they can flag it and they can take down the post. Okay. But I have personally not seen it, or at least I'm not aware of it. It's like there is a separate service which is running, which is checking across all the medias and finding for the copyright violations. Okay. Because a lot of people post a lot of songs, a lot of content. If the songs had the infringement as such as YouTube has, 90% of the posts on Instagram would have been blocked. Okay. Need eventual consistency. Eventual consistency for what? Instagram is built on eventual consistency. Okay. We are talking about likes. Yes. Cool, guys. If this is good, let's move on to our phase 3 of the diagram, which is final architecture diagram for Instagram. Same design we can use for LinkedIn, Twitter design, and Facebook. Yes. Okay. With minor modifications. Let's start with the user journey here. I'm going to take this here. Just one moment. Okay. All right, guys, let's have a look at this diagram. I'll give you guys 30 seconds. Have a look at this diagram properly, then let's start explaining it. Okay, 10 more seconds. Cool, guys. Now let's start discussing end to end. See what I told you? In terms of social media, there are two main components. One is this your database part where you're actually uploading the content. Second is your newsfeed generation and publishing. Okay, let's take one by one step at a time. This is, I'll call as flow 1. This I'll call as flow 2 and flow 3. So flow 1, what is happening here? As a customer, as a user, I updated a post or I added a post. Or think of like uploading a post. Once I upload a post, what will happen is it will go to my application server. If I have uploaded a post, I have database here. One is my metadata DB, one is my post DB, one is my video and photo storage. Okay, we already talked about video and photo storage, which is going to be my S3 here. We talked about the post, we talked about the metadata DB. Now, my post, all of this will have a cache. So I have a metadata cache, I have a post cache, I have a media cache. So my post will go here in the S3 part. It will go to the DB schema of post. It will have a metadata associated with it, which will contain about like comments and all those links. Once it is posted, now the second part is how it is being pushed to my followers. Correct? That is what you call as newsfeed generation and publishing. So two categories will happen if I'm a celebrity user or if I'm a non-celebrity user. Okay, let's start with non-celebrity user. If I'm a non-celebrity user, it will immediately be pushed to my followers. So there will be a cache on top of it. This is my feed notification service. There's a cache server holding feed. So as I said, a separate layer of DB is not required for newsfeed generation. You can store that in a cache. And these two icons that you're seeing, two cylinders, that represent there are multiple blocks of cache. Okay. Here also, if you see multiple blocks, where you see multiple blocks. And here also, if you see 1, 2, and 3 kind of a CPU structure, it means these are multiple servers. Okay. So these are layers of servers and layers of cache. So coming back, if I'm a non-celebrity user, the moment I have posted it, I would get a response, a particular post ID. So I can see it on my timeline, right? Or my profile page. Now, how would my followers see it immediately? Once it is successfully posted, it will be pushed to the newsfeed generation service for my followers. So it will be pushed in the cache, it will go to the feed notification service, and let's say user B and user C are my followers. Immediately, user B and user C will see my post after this upload in their feed. This flow crystal clear to all. Flow number one. Come on, guys, quick in the chat. Let me repeat it what I said. Flow number one, we talked about when a user will upload a post, how it will be stored in the database, how it will be passed to the newsfeed generation service. One moment. How it will pass to the newsfeed generation service and how it will be pushed to the user followers of it. All of this end-to-end flow we talked about here. Okay. This notification service, think of like publishing service. It's just notifying our followers, right? That's exactly what it is doing. So this is the cache where it is reading from it. That's the same cache where newsfeed generation is working on, and that's how it is generating. Now, the second category, what if I'm a celebrity user? So in case of celebrity user, what will change? Until this part, it will remain the same. You uploaded a content, a celebrity user uploaded a content. Now, in the newsfeed generation service, we will let them to have a call to the get feed. This is for celebrity user use case specifically. Once they make a call to the get feed, then in their newsfeed generation, that is when the celebrity post will be added here. And then they will see in their post for user B and user C. That's the only difference. Okay. Everybody, one moment, guys. Everybody crystal clear with the end-to-end flow here. What is notification service communicating to the web server? What is notification service communicating to the web server? Because your web server is something which the user B and user C will be connected to. Okay, so it will generate an event that, hey, now we are ready to send this newsfeed generation to user B and user C. Your client will get the response. Your client will not get the response from the service directly. Your client will get the response from server. That's why. One moment. Arrow between application server feed generation key, application server feed generation key. Okay, is for non-celebrity user. No, that is for celebrity users. That is for celebrity user. Can we go through cache server holding newsfeed cache cases? Okay. Okay, cool. Yeah, let me repeat it because it looks like there is some confusion or something is not clear. Let me repeat it. First thing first, until the upload part, everybody is clear. Metadata, comments, metadata, likes, comments, all of that metadata. Okay. Let me clear this part. Let me come here. Let me take one by one. This is something that we have discussed in phase 1 and phase 2 as well. I don't think there is anybody who is not clear with this part. Everybody is crystal clear with this part, how it end-to-end works. A successful upload will return your post ID. We talked about the APIs, etc., etc. Okay. So for a moment, let's stop. Let's assume that this is not in our diagram. Let's focus on the part which is not discussed yet, as which is right in phase 3. Okay. Once it is successfully posted, you will have some post ID generated. Okay, some post ID generated. Now what happens is, now it will be divided into two categories, whether you are a celebrity user or you are a non-celebrity user. So I'll define it as C and I'll define it as non-celebrity, NC. Okay. So user A is there. It can be celebrity. It can be non-celebrity. I'm talking about both cases. User B and C are the one which are followers of A. This part clear? User B and user C are followers of A. Okay. Now let's start with non-celebrity user case. It's easier to go through. In a non-celebrity user case, immediately when my post is uploaded, I am going to push it to my newsfeed generation service. So it will be immediately pushed to the feed of user B and user C. All agree with this? In a non-celebrity user case, it will be immediately pushed down to my followers. So user B and user C can immediately see it in their transform lines. Okay. Now, coming to the celebrity user use case, I'll mark this as done. I'm making it a checklist. Coming to the celebrity user use case, until this part, till you get the post ID flow is still same. Now, the only difference is I will not be pushing it to the newsfeed publishing service here because if I push it, there is going to be millions of user B, C, D, E, and so on and so forth. So what I'll be doing is I will let my followers pull it. So I will let my followers pull it means they will make a call to the get feed. For example, user B, user C, they refresh their feed. That is what you call as get feed. So from their get feed, I will have it in my newsfeed generation service, but I will wait till my followers actually wait for the feed or till their feed is refreshed. Either way. So if their feed is refreshed or they make a call to the get feed, that is when the celebrity user post will be pushed down to them. This is what is representing here. Now everybody clear? Come on guys, quick in the chat. Celebrity user, non-celebrity user. Now the flow is clear to all. Okay, let me answer the comment here. Okay, cool. For celebrity user, feed notification service will not work. Feed notification service will work in the case, one moment. Feed notification service as a publishing service, it will not work, correct. Okay, so they have to refresh the feed. That is when they will be notified of that post, which will be generated from this. Okay. All right, guys. Will cache servers communicate with the application server? Yes. You got a request, goes to the application server. From the application server, reading from the cache itself. Do we need cache before storing to DB? Do we need cache before storing to DB? For this one, like for newsfeed generation? Okay. Here we already have the cache. If you're talking about metadata or post of video and location, we already have the cache here. Okay. Is it required? Yes. The purpose of cache is to give a faster lookup, right? Before storing to DB, I mean, the usual flow is you store in the DB and then you upload in the cache. Okay. In the rare case, let's say DB and cache are not in sync, that is when you push it to the cache. Those are three categories we talked about for cache invalidation. But the usual flow is you will upload in the database, then you'll upload in the cache. Okay. All right. One moment. This is just news feed diagram. We are not discussing like shares and other services. Shares definitely we are not discussing here, right? Like, since as I said, like is not going to be a different service altogether. Like, comment, and all those things, these are not different services, right? They will be stored as part of this metadata here. For a particular post to get into newsfeed, we have to take post ID, meta ID, likes, and media ID to show it to user, right? Whatever thing that you want to consider, but I have not designed the schema for it, but let's see. Whenever you want to show it to the newsfeed, in terms of newsfeed, you definitely need the content ID, which you get from here. So post ID is definitely required. After that, you're going to see about, obviously, the post ID will also contain its metadata, which includes likes, comments, shares, and everything. Okay. So whatever you need to get, pretty much you'll get from your DB layer here. There's nothing separate that you need to add. Follower web server is also connected to metadata DB for follower likes. Follower web server is also connected to metadata DB for follower likes. Mm, When you say follower likes, what does that mean? We are not segregating likes between followers and non-followers here. There's only going to be one like, which is given a combination of followers and non-followers. Okay, cool. All right, guys, any more questions? All good? Cool. Let me clear this one first and we can talk about this. Same will go. This is Facebook newsfeed architecture, but pretty much the same for Instagram and Twitter as well. Okay. Let's take this guy. Let's move on to Sublime here. Follower, don't follow, comment and likes. Follower, don't follow. Okay. These two parts. If you want to store, one moment, guys. If you want to store followers and non-followers, that's a different mapping. That mapping is there in a simple SQL databases. Postgres will do for it. In terms of likes, comments, or share, we do not show, at least we do not show to the user for sure. They might be doing some internal translations. We do not show how many followers versus non-followers have the likes for it, or comments for it, or shares for it. Analytics is there where you can say, like, if you have a professional account, you can compare like how many followers have like versus non-followers have like. But that doesn't mean we need to keep in two different databases. Okay. All right. Cache only store 20%. Then if new post upload by celebrity, then how it will fetch from cache server. Cache only store 20% of the content. If new post upload by celebrity, then how it will fetch from the cache server. Cache will be updated, right? See, understand this part again, which I explained yesterday. Last part. Whenever you're watching this pre-generated feed, which is coming from the cache, forget about 20%, non-20%, ignore that. 20%, I'm talking about the total cache data, right? Whatever the content is. This news feed generation is a different cache. This is pre-generated feed. So think of like 500 items here, 50 into 10, okay? Those are two different levels of cache. In the diagram also I've created very clearly two different caches, okay? This cache for pre-generated feed, this will not contain the celebrity user post. When you will refresh it, then it will come here. Okay. That's what I'm saying. In the cache, which you're talking about for a pre-generated feed, it doesn't make sense to keep the celebrity user. If it was, then you will see the celebrity user in between the feed. You will not see the celebrity post in between the feed. Whenever we want to push the celebrity user, we'll just put it on the top of it. Okay. All right. That's being said, this was for your Instagram case study. Okay, or social media case study in general. I'll take this part, I'll mark this as done. Now we have few more categories of case studies. We have WhatsApp or any messaging service. We have file sharing service like Google Drive or Dropbox or OneDrive. We have streaming service like YouTube, Netflix, and we have taxi sharing service like Uber, Grab, Ola. Okay. So let's start with WhatsApp, Messenger, or Telegram service. Let's talk about this real quick. Okay. Let me connect my charger, guys. Quickly, give me 1 minute. Book my show designed for concurrency control. Okay. Well, if you just want to discuss concurrency control, that we'll do in Uber as well. Okay, but let's see if our time permits. We can take one online booking service like Ticketmaster. Okay. Concurrency problem would be the same in Uber also. When you try to book an Uber, there are multiple drivers waiting, so on and so forth. All it is. Let me quickly connect my charger, then we'll start with our new case study for WhatsApp. All right, guys, I'm back. Let's see. Okay, one question is in the chat. Let me take that. Feed generation service pushes feed offline to the cache, which is read from the user accesses timeline. Yes. Which service reads the feed in real time for which? The case of celebrity users. It's not a real time as such. Okay, understand this again. Let's go back to the previous diagram. Let's get it here. There you go. This newsfeed generation service, when we are pushing the data into the cache, which contains my pre-generated feed. Okay. Now, whenever a feed is refreshed or whenever a feed is requested by the client, either they app refresh or they refresh our end, what we do is we pass the celebrity user post there. It doesn't need to be a necessarily service, right? Because there's going to be limited number of those accounts. Let's say 1,000, 10,000, 50,000. It's not billions of celebrity users. So those limited number of accounts which a particular customer follows, that we can generate pass directly through it, okay, in a regular interval of time. We don't need a dedicated service for that. If you want to create, completely fine. You can say separation of concerns and those part, but we don't need to do it. Okay. So what we can do here is, as part of the newsfeed generation service, every time there's a refresh being called, in that refresh, you can just have a lookup. If out of those accounts where have celebrity users, if there's a new post, you directly pass it to here. Okay. And that will be added on top of it here. Cool. Let me clear this. Let me answer it. An interview is good to draw diagram first and then jump into each part of block based on ask an interview. Good to draw diagram first and then jump into each part of block based on ask an interview. See, that thing I already answered in the very first class when we started doing this case studies. I gave you something called template. So in the template, I mentioned all of these 11 12 items we discussed was part of all the case studies we are discussing. So some things are going to be extremely important. The interviewer cannot skip the DB schema. They cannot skip the API design. They have to go through it. Okay. Component level design, how detailed they want to do depends upon your role or what is the nature of the interview, so on and so forth. There can be a product interview, there can be a system design interview, there can be an infra level interview. So how detailed they want to do it all depends on your role as well as the nature of the interview. So in the first initial 5 minutes of conversation, give the template, make it very clear which conversation they are interested to know about, remove everything else, and then focus only on that part. That's how you drive the conversation in terms of leading into a system design interview. And number two, whether you have to draw a good diagram first and then you have to jump into each block, do it parallelly. While you are drawing the diagram, mention about why you are drawing that, like what's the reason behind that, and so on and so forth. So it's not like you will draw it and then you try to explain this because you won't get time for that. And if the requirement change, if the interviewer cross questions something and you need to rechange it, that's not a good experience. So while you are drawing it, same goes for your DSA interviews also. While you are coding it, just make sure you are in alignment with what interviewer is looking for. And if something needs to be changed, you can change it then and there. Cool. All right, guys. If that is good, let's move on to next case study. This is our case study 3. Designing messaging service like WhatsApp, Telegram, or Messenger. Okay. All right, guys. Before I move to WhatsApp, just want to ask you one thing. Have you guys used Messenger? Okay. Most of you would have used Facebook Messenger and you guys would have used WhatsApp as well. Can you tell me what is common between them? Easy to identify. Both are chat applications. What else? Both have a last seen service. Both have read receipts. What else? Okay, both have stories. Both have group chats. Both have audio and video calls. Easy to identify in terms of our messaging service. Both of us are messaging service basically. Can you tell me what is the difference between the two? Come on, guys, quick in the chat. Status upload. Status upload is there in Facebook also, not in the Messenger itself. Anybody? There's a very big critical difference between. Okay, let's understand one by one. First thing first, Messenger is also a messaging application, messaging service. WhatsApp is also a messaging service. But there is a very critical difference between these two messaging services. Now let me think if anybody gets the hint. It's not about mobile number or email, guys. Think more than that. I'm not talking about Facebook, I'm just keeping to Messenger. Okay, let me repeat the question again in case you're getting it incorrect. One moment, guys. Before you give the answer, understand the problem statement clearly. The problem statement is Messenger is also a messaging service. WhatsApp is also a messaging service. Now, there are many things which are common here. There are many things in terms of features which can be different there. Okay. Mobile numbers, emails, I'm not concerned about it. Features also, I'm not concerned about it. At the core, it's a messaging service. At the core, this is a messaging service. I can message here, I can message here. My question is, there is fundamentally something which is very different in these two messaging services. What is that? Now answer me the question. Come on, guys, quick in the chat. Offline message delivery. What is offline message delivery? Messenger is part of FP, WhatsApp is individual. Which company owns WhatsApp? Okay. Anyways, cool guys, let's see the answer. I was not asking in terms of any function requirements or UI experience or in general like infrastructure level difference. No, there's a multiple core difference between a messenger and WhatsApp. Forget about standalone application or not. I'm not even asking about that. My question was, if as an end user, I can message on WhatsApp, and as an end user, I can message on Messenger. As an end user, I can message on Telegram also. But there is a fundamental difference when I message on WhatsApp versus a message on Messenger. What is that? My chats at Facebook Messenger, are these stored in Facebook server? Yes or no? Okay. You guys are saying yes. We'll see. My chats at WhatsApp, are they stored in Facebook server? Okay. We'll talk about it. Some of you are saying yes, one of you is saying yes, other of you are saying no. Let's talk about it one by one. Even if you know that answer as an engineer or not, that's a secondary part. Forget about it as an engineer. As an end customer, you can get the answer to these questions. Okay. How you can get the answer as an end customer? Just think about it. Let's talk about Messenger first. In my Facebook Messenger chats, is there a backup? Do you anytime backup for your Messenger chats? No. What do? You get your Facebook Messenger app or website or whatever platform you are using. You log in and you're able to see the chats. That's how you do. All agree? You don't back up any chat. Whatever you do is you just log in. Whatever website you are using, whatever platform you are using, mobile or a web device, you can just log in, you can see the chat. And you can see the chats from the time where you started using Messenger. And even if you uninstall, uninstall, and reinstall that app, all chats will be as it is. Nothing will change on the chat itself. All agree? If I uninstall my Messenger and I reinstall it, my chat will still remain the same. Why? Because I don't have to take a backup and then upload it. My chats are already stored in Facebook server. Everybody crystal clear so far? One moment, guys. One moment. Everybody crystal clear so far? Messenger part, the part one of the question, they are stored in FP server. You guys said yes. I'm proving to you why it is yes. There's two parts. This is a theory. This is a proof. Even if I uninstall and restall it, if it was not stored on the Facebook server, I need to upload those chats somewhere. Means I need to take a backup somewhere. I don't take a backup, I don't upload, means it is already stored in the server side. They have already reserved for me. All agree with this? Okay. If our messenger part is clear, now let's talk about WhatsApp for a minute. In my WhatsApp, does my chats have an option of backup? The answer is yes. I need to back up my chats. And when you back up your chat, what option does it provide you? Correct. The option it provides you is to connect via Google account, upload it to Google Drive. Now, this was under the ecosystem of Meta, right? You have the same platforms, you can connect to it, you can log in, log out whenever you want, it's stored there. The moment Google account comes into picture or Google Drive comes into picture, it is beyond the control of Meta. Agree? Meta does not own Google Drives, Meta does not own Google accounts, right? Now, what does that mean? The chats that you have created, if it is being asked for a backup, means it is not stored on the server. If it was stored on the server, why is there a need to do a backup? Logically think about it. If the chats are stored on the server, why is there a need to do a backup? You can just log in to your WhatsApp and you can always get the chat. Another way of looking at it. In my WhatsApp, if I uninstall it and I reinstall it, do you think my chats will be as it is? No. All chats which are not backup will be deleted. They will be deleted. Okay. So what does that mean? If they will be deleted or they will be lost, means they are not stored on the server for sure. If they were stored on the server, even if I'm installing it, reinstalling it multiple times, it will not matter because I'm connecting directly to the server. If you are being asked to take a backup, one moment, guys. If you're being asked to take a backup, means you have to own that data by yourself because that data is not being stored in the server. This part clear to all? Okay, cool. So let me answer this first. WhatsApp backup data. Let's say you did the backup on last month. Now we are going to uninstall and reinstall it. Uninstall and reinstall it. What will happen in this case? You would get chats, but you would get chats from the backup, not from the Facebook server or any other server. And that is from your last month. My chats are not stored at Facebook app. Okay. Now let me answer the question in the chat. If my internet is off and I switched it on, I get the WhatsApp message. It means chats are stored somewhere. Your chats are stored somewhere, but they're encrypted. Okay. There is no backup being created for sure. And they're stored only till the part till you get the message. Once you get that message, that encrypted signal will also be deleted. Okay. But they're not stored somewhere for sure. Anyways, we'll discuss more that in the detail. But is the first statement clear here? The difference between a messenger and the WhatsApp is that messenger, my chats are stored in the Facebook server. I can log in, log out whenever I want. My chats will remain intact. In case of my WhatsApp, it is not stored on the Facebook server. So if I reinstall and uninstall it, or if I install and reinstall it, my chats will not be same until unless I have not taken the backup. This part crystal clear to all. Come on, guys, quick in the chat. Okay, that is part A. Part B, which I want to clarify about WhatsApp before we start with the design. You must have heard this statement: WhatsApp chat are end-to-end encrypted. Even it shows in your WhatsApp also when you message someone. WhatsApp chats are end-to-end encrypted. What's the meaning of E2 encryption? E2 encryption means client side, somebody who is a sender. The moment you send a message, it is encrypted from the client side. And the moment it is received at the receiver side, it is encrypted. That is what you mean by end-to-end encryption. Obviously, pretty much all the communication protocols that you do, in flight, they provide you encryption. In flight means till the part it goes from sender to the receiver. Now, whether there is a separate encryption on sender or receiver, that's a different part. But in flight, definitely there is encryption. Otherwise, everybody can just hack anyone's data, right? If there is no um, encryption during the channel itself, the HTTP and HTTPS, basically that's the difference. That HTTPS is the secure protocol. So during the encryption, during the time you have a connection set up, your data is encrypted and safe. At the client side or at the receiver side, somebody can hack it, but during the transcription, nobody can do it. This chats, what we are talking about end-to-end encrypted is definitely during the channel, it will be transferred. That's what you're transferring over TCP or HTTPS protocol. In this case, it will be a TCP protocol. Apart from that, the moment you hit a send, from that part till somebody receives your message, it is completely end-to-end encrypted. So even though momentarily they will be storing something in the database, they cannot read it. It's a hashed message to them. They cannot access or read the message. Okay. These two parts crystal clear to all. Number one, WhatsApp chats are not stored in the Facebook server. Number two, what does end-to-end encryption means? Okay. All right. If this is good, let's quickly revise what we discussed as part of today's session. Okay. Which part? Which part you want to explain again? Just tell me the line number. End-to-end encryption. Okay. See, end-to-end encryption is the moment you send a message from the client side till the moment somebody is received at the server side, they are end-to-end encrypted. You send a message, now it will be encrypted form. Somebody received a message, that is also an encrypted form. They will decrypt it at the receiver side only. And they will encrypt it once you do. Can we encrypt the images? No. Content is not encrypted. Messages are encrypted. Okay. Your content, your documents, your location, your videos, your contacts, these are not encrypted. Messages are encrypted. Okay. Anyways, coming back to this. What I was talking about is end-to-end encrypted is in terms of a quick diagram. There is a client, there is a server, there is a communication. Okay. As long as you have a HTTPS, whatever you're doing till the part you have this transition, that will be secured. So nobody can come and hack the data in between. Okay. You send something, either it can be hacked here or it can be hacked here. It cannot be hacked here for sure in HTTPS. Okay. I mean, there are loopholes that you can find it. I'm not saying it is impossible, but it's difficult. If you put encryption here on a client side, and if you put encryption here on the server side, this anyways will be encrypted, be it HTTP or TCP. For WhatsApp, it's going to be TCP protocol. Okay. So if it is encrypted, in that case, my client, you cannot hack here, you cannot hack here, and definitely you cannot hack here. That is what end-to-end encryption means. Till the part you send a message, till the part it's received by someone, nobody else can read that message or access that message. Okay. WhatsApp use WebSockets. WhatsApp use WebSockets. WebSockets works on TCP connections. Okay. Is FB Messenger chats also end-to-end encrypted? No, FB Messenger chats are not end-to-end encrypted. How delete on both device works if we're not storing message metadata post delivery. We'll talk about it, guys. We'll talk about both the scenarios. Okay. Deletion of message doesn't mean it needs to be stored in the Facebook server. There is going to be some sort of database which is going to delete that, but it is not stored on the Facebook server. That's what I'm referring to. Okay. Think about the destination side since keys were entered the client side. No, client side has a separate encryption, a destination side has a separate encryption. That's why I said two different parts. Encryption at client side, encryption at separate side. Okay. So the decryption key would be different at the receiver side, decryption key would be different at the client side. Okay. All right, guys. We'll discuss more about it. We'll deep dive into all of this communication. But prior to that, these were the basic parts I wanted to clear about. That being said, let's quickly revise what we discussed as part of today's session. First, we continue with our social media design, Facebook, Instagram, or Twitter in general. We'll talk about how many feed items to return in each request. We talked about 50, and then we talked about the bitrate adaptation. So we took the example of YouTube to understand how bitrate adaptation works in terms of quality. Here, we do not have the quality segregation. So what we can do is, even though I cannot change multiple quality here, what I can do is, I can reduce that 50 count to 20. So to have a good customer experience. Then we talked about feed ranking here. We talked about which metrics are captured as part of feed ranking. Then we moved to data partitioning or sharding logic. We have two options here. Either we can shard based upon media ID or based upon user ID. If I do it based upon media ID, it leads to two problems. What about the account which has a lot of content? Whenever I have to generate their profile, it will take me a lot amount of time. Number two, what if too many people post the same photo or those for the viral post, the distribution load will become way too much insignificant to handle. Okay. So it become way too much significant to handle. In that case, my media ID approach will not work. So what I'm going to do, I'm going to keep my sharding or partitioning key as user ID. So it will help me to understand all the user information in one partition. Okay. Then we talked about caching, pretty much the same. We will discuss 80 terabytes of cache memory per day. We talked about cache eviction policy, cache miss case, all those so forth. Load balancer, pretty much the same thing which we discussed in our last design also, and then analytics and telemetry. On top of that, we talked about what happens in case I have to identify duplicates. So for duplicates, before I upload something, I'm going to check it in my hash code, whether that image or video or content is already available. If it is available, I'll reuse the previous hash code, else I'll upload it. Okay. We also talked about media ID versus post ID, kind of an array traversal here. What happens here exactly? Then we move to the final design. This is the phase 3 of the diagram, and I'll share that in your WhatsApp channel as well. Now, case study 3 that we have just started. Case study 3 is designing messaging service like WhatsApp, Telegram, and Messenger. So first thing I want to clarify before we even start the case study, the difference between Messenger and WhatsApp, the core difference is chat in my Messenger are stored in the Facebook server, chats in my WhatsApp are not stored in the Facebook server. You don't need to be an engineer to identify that. What you can do is you can just check from the application platform itself. Facebook Messenger, I'm not keeping any backup. I can restore it, uninstall it whenever you want. Okay. And I will see my chats will remain intact. But in case of WhatsApp, that is not the case. If I don't take a backup and I uninstall and restore it, my chats which are not backup will not be there. Means there is no server which is storing my chats altogether. Okay. You are responsible for creating a backup of your own chats. And second thing which we talked about it, WhatsApp chats are end-to-end encrypted, which means from the client side, which is sender side, and to the server side, which is receiver side, it is end-to-end encrypted. Okay. All right. Everybody crystal clear with today's part? Everybody crystal clear with today's part? Okay. Now let me answer some of the questions. I recently saw WhatsApp ad saying images, videos, audio messages, everything is encrypted. Official WhatsApp commercial. I've not seen that commercial, so I won't comment on it. But there is some signals that you can get. I will not go into details of that because I should not. In terms of end-to-end encryption, as of now, think of it. There is encryption on the sender side, there is encryption on the receiver side. And as of this moment, consider there is encryption on everything. Okay. There is no storage overhead storage device. There is no application side, right? For WhatsApp, there is no storage overhead storage device. Is there for application side? I didn't get the question exactly. There is no storage overhead storage device. Is there for application side? No, they will be stored. See, your messages are definitely being stored for sure. It's just that it is encrypted. It is not stored on the Facebook server end. They will be temporarily stored in the database for sure. And the moment you got it delivered, it is deleted. Okay. So whatever storage that you're having, whatever chat history that you're having, that is not exactly replica in the database. It's in your client device altogether. Okay. Or in the backup that you have. Once you delete it, it's permanently deleted. You cannot gain it back. That's what I mean. So for example, let's say by mistake you deleted some chats and now we're expecting it to get it back from the Facebook server or whatever server, you cannot get it. Okay. So on that case, there is no overhead. If it's stored on the server, it can be decrypted. It's not stored. That's what we are saying. Okay. All right, guys. If everything is good, let's wrap up the session here for today. Let's catch up in the next session. We'll continue with our WhatsApp system design. Okay. All right, guys. Thanks for joining in. Have a good one. We'll continue with the WhatsApp system design in the next class.